Are you ready to start now, Dr. Irby?
Yes, I think we can start.
Okay.
It's 2:03, so if people join the session, we can let them in as they come.
Okay. So good afternoon, everyone. My name is Tariq Abdel Salam. I'm the director of the Center for Sustainable Energy and Environmental Engineering. I will be the moderator for this webinar. Our webinar today will be on the role of forest products in decarbonizing the built environment. Next slide, please. Before I introduce our speaker today, there are just a few items, housekeeping items. The recording of this webinar will be available to all attendees in our YouTube channel. Also, the presentation will be emailed to all attendees. Please, if you have any questions, write them in the chat and we'll answer the questions at the end. And also, I will show the links to the feedback and to the center website. So we'll value your input and your feedback. Okay, so our speaker today is Dr. Marley Irby. She's a forest engineer with a PhD in forest resources, specializing in sustainable bioproducts. As a pollution prevention specialist at the ECU Center for Sustainable Energy and Environmental Engineering, she leads initiatives to help manufacturers adopt pollution prevention and source reduction strategies. Her work involved collaborating with teams to conduct energy, water, and lean assessments for interested manufacturing companies, engaging stakeholders, organizing courses and technical workshops for industry professionals, and delivering presentations to raise awareness about pollution prevention in the manufacturing sector. Before joining ECU, she conducted research on the physical and mechanical properties of hardwood and softwood lumber. She also has experience in sales and customer service within the forest products industry. With this, Dr. Irby, please start your presentation.
Thank you very much, Dr. Tare, for the introduction. Well, good afternoon, everyone. Thank you for being here this afternoon with us here at the center, and very excited to bring this presentation today that is connected to my background. So today I'm just going to be talking about the role of forest products in decarbonizing the built environment. I want to apologize if you see me looking on to the right. It's because I have two screens, and since like my slide deck is on the right, so I had to look at that way. So to be able to look at yours screens as well. So just as a brief introduction of what built environment means, please consider that the built environment is more than just residential buildings. It's everything where we interact daily. Your office, the school, colleges, hospitals, bridges, all the infrastructure where we interact daily. But today I'm going to focus on bringing information of the forest products and how they can play a role in helping us reduce carbon emissions in this sector. But before going in deep into what forest products are and how they help us, I'd like us to first start having the notion, for those that might not be aware, of the fact that forests are nature-based climate solutions. And as such, they are our allies when talking about strategies to reduce carbon emissions. But not only carbon emissions, they also provide us with other benefits and services for society. So in this slide, we can see a few highlight or key points of forests as natural climate solutions. The most important is that forest and forest products represent the largest carbon sink in the United States. That this slide is just, I'm focusing on the US, but we know how important forest ecosystems are around the world. They provide very similar services. Of course, this is going also depend on the practices on how these ecosystems are being managed. So for us to consider forest products, or more specifically wood products, as natural climate solutions, it's very important to know that these products must come from sustainable forest management lands, because if they are not certified, then we won't have security that this is actually coming from a sustainable process. Other things to consider about forests is that every year, forest lands and harvested wood products and urban trees offset more than 11% of the U.S. greenhouse gas emissions. So this highlights the importance of these ecosystems for the U.S. and for other countries in order to offset greenhouse gas emissions. Other services that we get from them includes clean air, fish and wildlife habitat, recreation, and traditional and cultural uses. But also we know that the forest provide us with important economic benefits. And just here in the U.S., our National Forest Service lands contribute to over 11 billion to the U.S. economy and sustain nearly 150,000 jobs. In this slide I bring today, I just want to highlight something that I found very interesting. This infographic, I saw it a few weeks ago, and I think it's very good because it helps us see where our forest position when we talk about natural climate solutions. As you can see, forest ecosystems are at the top, which means they are the ones that provide the most opportunities for us to mitigate global warming. And so this infographic is showing, I think, is 20 pathways that are considered for natural climate solutions. And in that category of forests, we can see 6 strategies, starting from reforestation, ending with fire management. But I want to highlight, but in this category of group, forest products, more particularly wood products, are included, which means wood products and using more wood in our buildings and to decarbonize the built sector, it's very important. And you can see it there as implementing improved plantations and natural forest management. If you're curious to understand more this infographic about what it means, you can check that report where I found it when I found it. But essentially, what is showing the great light color is representing the cost-effective mitigation levels for that strategy, assuming global ambitions to hold warming under 2 Celsius degrees. And the dark gray is indicating a strategy that is considered low cost. Now I'm going to talk about decarbonizing the built environment. So decarbonizing, I think the name says it's pretty easy. We're looking to reduce the carbon emissions that comes from the building sector. From a report that I found in 2019, it was showing that buildings represent 20% of the global greenhouse gas emissions, which translates in 12 billion tons of carbon dioxide per year. Now, these numbers, I think, are much higher nowadays. I just didn't have the chance to put that most up-to-date report, but just for us to have a reference on how much this sector contributes to our climate. And on the right, we can see a pie chart showing a breakdown of those emissions and where they come from. So the biggest portion of emissions would come from indirect emissions. So those are off-site emissions, like come from the generation of electricity. And then we have direct emissions at 24%. And this has to do with all the activities that are occurring in the building. For example, cooling and heating, etc. And then we have an 18%, what is called embodied emissions, also embodied carbon. And this is all those emissions that come from the activities linked to the materials that were used in the building. So think about the extraction, production, transportation, installation, the whole life cycle of the material. So once we understand that, the where is that the emissions coming from, it can help us to see where our forest products can fit to support decarbonization strategies in this sector. And so just to repeat to connect from the slide before, forest products are a powerful nature-based solution, but very important only when they come from sustainably managed operations. And if we support or encourage more well-managed forests, we can benefit on more carbon sequester from the atmosphere. And we'll see how this works in the next slides. So now we can talk about forest products. So I started in the macro vision, forests as ecosystems, providing benefits, providing services to society, right, as a natural climate solution, and then now a forest product. So these are all the materials that can be obtained from trees and other forest vegetation. And the purposes vary. They can be for construction, paper, and other industry applications. More broadly, we can categorize forest products as timber products or non-timber products. Non-timber products are not relevant in the context of the built environment, but I like just to have it here for reference so you can understand or remember that forests offer us more than just wood. They come with a plethora of products and services. So in the timber products, we can see a vast spectrum of materials that comes from the harvesting and processing of trees. It can be structural lumber, wood composites, packaging, etc. And in the non-timbers, you will see other products like berries, nuts, all kinds of seeds, perfumes, fibers, medicinal plants, etc. Another form to categorize forest products is this one that I created here, starting with traditional solid wood products. This is what we probably are very familiar with when we see houses, especially here in the US. They're typically framed with dimensional lumber. So these products don't have much processing. It's just cutting the tree, processing the log, and transforming it into boards. It can be 2x4s, 2x6, 8s, 12s, things like that. They vary in quality. There's a whole process just to understand what levels of strength and flexibility these products have. We can also find poles, posts. These are the ones that we can see here in the US in our neighborhoods for electricity, right? And there is a lot of research on those to have this product standing and lasting. And also we can find ties and timbers that are used in the railroads. And then we have the engineered wood products category. So this category is very interesting because it contains a whole plethora of products that we can use for structural or non-structural applications. Here I highlight a few: plywood, OSB, which is oriented strand board, MDF, which is medium density fiberboard, glulam, parallel strand lumber, CLT or cross laminated lumber, LVL or what they call it, laminated veneer lumber, and the most recent term that we see out there, mass timber. But there are others. So an engineered wood product is a product or a material that is made of wood elements and is combined with resins or adhesives to make it stronger. And so these wood elements are processed. So it can be a strand, wood strand, fibers, particles, veneer, etc. And what this does is that it helps us create more consistent and reliable products. We can even increase the strength of a material by processing it this way. And they usually have less defects because they can be removed to make bigger pieces. And just another category just to highlight for your knowledge is forest-based bioproducts, or everything within the forest product is a bio-based material, just to clarify that. But we separate them sometimes a bioproduct, which is like lignin-based, adhesives, foams, bioresins, nanocellular, cellulose, biochar. We can get all of this from from our forests or residues, and so this way we can show that um, we can find additional value from the products that we extract from forests. Now that we understand these products, here you can have just a quick picture to visualize the products I was talking about. Starting from the left, you can see the poles. In the middle, you can see dimensional lumber. On the right, at the top, you can see panels of CLT, which is considered a mass timber product. Under the poles, you can see the ties that are used for the railroad. Another picture of mass timber. I think this is glulam. Then at the bottom, you have the different panels like plywood, OSB, MDF, chipboard, and on the right at the end, this is fibers. I think just to make nanocellulose. I don't remember that one, but just giving you an idea. Now we can talk about wood. I put it in the title as the ultimate sustainable big building material. I know it might sound like a lot, but to be honest, when we think about the technologies that we have, we still haven't been able to come up with a material that have um, the features and capacities that would have in the context to incorporate a material that can be sustainable, renewable, and biodegradable. To the top of that, it has the feature of sequestering carbon emissions, which is something that we still are investigating, and the few technologies that are out there still are very expensive. So that's the relevance of wood today, and that is why it's now being more frequently featured in conversations around the world as the most scalable material for uh, reducing carbon emissions, and it's also being called as a climate smart material. And here in this slide, I also highlight a few points just to back up this statement. Like I said, is renewable and sustainably managed. Here in the US, our products mostly come from sustainable managed lands and certified. But we know and understand that is challenging in other countries, and there's a lot of work to do in this area. But it's possible. It's definitely possible, as we can see the examples here in North America with the forest. And also, they have low carbon footprint. We have the multiple life cycle assessments for researchers. They prove that producing wood products has a much lower energy consumption, especially when you compare it with other traditional materials like concrete, steel, cement, glass, etc. And the feature that I mentioned, the carbon sequestration, each cubic meter of wood stores roughly 1 ton of carbon dioxide. Also, wood can support green building goals, and you can get credits with the LEED certifications when you select wood products that are certified. Another thing that is very important to highlight is that many companies that produce wood products, they focus on showing their supply chain and how their operations are. So certifications like SFI or FSC show us that these companies are ensuring that there is protection for biodiversity, that they are preserving water bodies, and also involving the community. So this shows that the industry is committed to show transparency in their business and practices. And lastly, just to highlight that when you use wood, you have the opportunity to support circular regenerative systems, because you can design a building with the with the principles of recycling or reusing, which means you are producing less waste, which is the whole concept of circular economy. And last thing here about wood, for example, here in the US, many mills burn wood waste. So those parts that are not sellable, like bark, the sawdust, shavings, a lot of mills, they reuse that and burn it and generate electricity. This means these factories are reducing the energy consumption from external energy sources, so it becomes more, more sustainable. And I think this is interesting because it could be a concept to replicate maybe in other industries, just to check for their waste and see if it has any potential to be reused, whether for energy or for another product, maybe sold to become part of another uh, product or service. And now we're going to talk about biogenic carbon. And the only reason why I bring it here is because I see that every time we talk about climate and the benefits of building with wood, this concept comes a lot. It's very frequent, but it just has to do with the carbon that is stored in the trees, in the biomass, including the wood building materials. So on the left, you can see the carbon cycle, and this is how forests interact with the carbon cycle, because they are constantly growing and removing carbon from the atmosphere. Then this carbon moves across the cycle in different paths. We know that the tree at some point will die, and if it dies, it will release the carbon to the atmosphere, but this doesn't happen immediately. This is a slow process. The same if the forest caught fire, it would release CO2. But the other path of carbon inside that cycle is when it goes to the wood products. You can see it there. So you have the feature of sequestering, absorbing the carbon dioxide, keeping it in the wood fibers, and then you lock that carbon. And when you harvest those forests, you are able to extract that carbon and keep it locked for decades. And that's the unique feature that we have from forests and wood products. It's a closed loop, and that's what it means, carbon, biogenic carbon. On the other hand, we have other materials that when they are extracted, they are emitting CO2 to the atmosphere. So these emissions remain in the atmosphere. Nothing else is happening. There's no way to offset that. And that's what they call an open system. And they also mention in materials that comes from they do fossil carbon. And on the right, I'm just showing a quick small picture about a piece of wood, just to reference that wood has 50% carbon in their fibers. And this process of carbon absorption and lockage in the fibers is it happens thanks to the photosynthesis process that occurs in all plants. Now that we understand that, we can talk a little bit about embodied carbon, which is another typical concept when we hear about strategies to decarbonize the built environment. So, like I said in the beginning, embodied carbon refers to the total greenhouse gas emissions associated with the materials and the construction process throughout the whole life cycle of the building or the product. So this is going to exclude the operational energy or operational carbon. And on the right, you can see an image there that shows embodied carbon, everything that happens during the manufacturing process, harvesting, is transportation, installation of the construction materials. And so think about embodied carbon not only for wood products, but also for cement, steel, glass, all the energy that was required to produce those materials. And then on the right, you have operational carbon for the building that has to do with the building energy consumption. So if we want to think about strategies to decarbonize the building, we have to think about the strategies that we're going to use in each of those areas. For the embodied carbon, or if you're going to target operational carbon. There is a lot going on for operational carbon. We can see it with better appliances, right, that reduce energy consumption, when you install LED lights, when you do inspections and keep your appliances up to date, working effectively. You could also incorporate renewable energy on site or outside those buildings, like wind turbines, solar panels, etc., or reducing in general your energy consumption. All those strategies will help you to tackle the issues of carbon emissions in this part of the building. Now, if you want to improve or increase um, your impact to decarbonize the built environment, then you also want to look at the materials that you decided to use in your design. And in this is the opportunity, because your material choice has a significant impact. And so when designing and planning your buildings, you also want to look for low carbon or bio-based materials, because this way you can also think in designing with the circular economy principles in mind for recycling, reusing, disassembling a building, and repurpose those materials for something else. And now I'm going to talk about mass timber. So mass timber, like I said in the beginning, is the most trending topic nowadays. And it's just a subcategory of engineered wood products. And mass timber just refer like these are products that are big, like big panels, large beams, and they are made this way so we're able to build for larger spans. So also very common to build high and medium rise buildings. Of course, with the building codes across the country, there's still challenges per state. It varies, but we are seeing a trend of some states starting, to open up to incorporate these structures, as the research is showing more confidently that these products are safe and good to perform structurally, just as any other material. And some of the benefits that has been attributed to mass timber include the speed of construction, for example, because these materials are lighter, tend to be lighter, so you can put them on site and build faster. It will require also less people to handle it, and that translates in cost savings as well. And you can also have the benefit of the reduced carbon emissions, and also an interesting fact that some type of mass timber products can allow tight construction, so you can reduce the air leakage in the building. And so here on the right, you can see two images of mass timber products being used. You can see they're like big panels. You can use it for the ceiling, the beams. The picture at the bottom is a warehouse. I was surprised to see this because I never seen one, but I think it's interesting to see more of this, like constructions incorporating wood into industrial or commercial buildings. And I don't know if I mentioned the beginning when I explained engineered wood products, but they are, again, just composite materials, lash composite materials. Like the CLT would be just pieces of lumber layered, like a sandwich, but they're put in a 90-degree angle. And here now I'm just going to bring an example of how these products are also used in real world. And this building was made in California, downtown Oakland. It has 16 stories, and it was mainly built with mass timber. I think the base has like 4 or 5 floors with concrete, so it will be like a hybrid building, but most of the structure has panels from mass timber. In this case, is plywood, and what else? Columns, mass timber columns. And the benefits they found, again, was speed of construction and cost reduction. The investors in this building said they were able to save around $30 million in the net project just for incorporating this material. And this one, I like to bring it as an example also, even though it's a very small building now, it only has 8 stories. This was called the Carbon 12 building. It was created or built in 2018 in Portland, Oregon. And this was a pioneer building here in the US because, like I said in the beginning, the building codes would not allow for tall buildings. I think the restriction was up to 4 or 5. And in this case, this building was built with 8 stories. But they had to work around with the state to be able to make this building. And now we have, I think the tallest building here in the US is 19 stories and is in Wisconsin. So another thing to highlight from these buildings is how you can see here in the picture on the right at the top, the exposed wood. Exposed wood in ceilings, floors, and beams is very interesting and good because it showcases the natural beauty of the product, and it has been researched and proved that when occupants are exposed to buildings like this, it provokes a biophilic effect. It improves the natural state of humans, so make them feel more comfortable, like closer to nature, and reduces stress. But there's still a lot of research ongoing in this area. And yes, this picture at the bottom also shows, like, for reference of how the panels look. As you can see, they're it looks like a light, of course. In the context of a building product, everything can be heavy, but when you compare it with other products, more traditional, this is very light. And so I'm just in my last slide, just for a conclusion. I would like just for you to go home and with the knowledge or the refreshing concepts that I discussed here today. More importantly, the forests are more than just trees, that they offer us a plethora of benefits and services, and connect them with the concept of natural climate solutions, because we're going to continue seeing them more probably in the future as strategies. In the long term. And also, no, I hope I was able to connect the importance of the forest products and how they can be incorporated to decarbonize the built environment. And the mass timber is also a trend that we probably will be seeing more in the future to participate in this strategies to reduce carbon emissions in the building sector. And lastly, just 2 things that I want all of you to go home with is thinking that material selection is very important, and not only for the building sector, but in any sector. Think about the materials that you use to produce your products, because each of them have an environmental profile, and it is important to know what ingredients, what is happening behind those materials, how were they extracted. And some industries are more clear or show more about this through their life cycle assessments or environmental product declarations. But I think it's important to keep those in mind. And if we don't see like they are where we need them to be, maybe have the opportunity to look for alternatives, find options, look for programs that can inform you on what would be a better substitute that can support your sustainability goals. And lastly, when I want us all to go home with this powerful vision of the future for construction, which I think it would be the combination of energy efficient designs, like what we talk about, reducing operational emissions, but also incorporating low impact materials like wood to reduce the embodied carbon. If we do this, I think it's a very powerful strategy that can significantly amplify the climate benefits for the green building. So that's all I have for today. I know it's very short, but I might give us space for questions if you have, or any feedback or anything you would like to add for this presentation. Thank you.
Okay, thank you very much, Dr. Irby. Any questions? You can unmute yourself or you can write your question in the chat.
Good presentation.
Thank you. Thank you so much.
Okay, here's one question. When you say each cubic meter of wood stores 1 ton of CO2, does it mean that the amount of carbon in 1 cubic meter of wood is equivalent to the carbon in 1 ton of CO2?
So that is a very good question. Let me see if each cubic meter would stores 1 ton of. Yes, because there is a calculation that it's done. It's based on the molecules that are in the carbon dioxide. There is a formula where you can calculate how much carbon dioxide is equivalent inside your wood product versus what is happening in the atmosphere. I don't have it here, but I remember that you can do the calculation and find the equivalence.
Okay, yes. I think because wood has 50% carbon on it, right?
Yes.
Okay.
But you had to make a
Roughly.
calculation. Yeah.
Yeah, roughly. Okay. Any other questions? Yes, here's another question. Are there any policies or incentives currently in place encouraging the use of forest products in urban development?
That's a very good question, and I think it's a mix. It's mixed. I feel like there's more incentive in certain states that are pushing more towards this. I see it more like in the West Coast, like Washington, Oregon, even California. Maybe other states not necessarily have the incentives just yet, or that people are necessarily aware. But I think we likely are gonna be seeing more of that, at least across the country for sure, and in the East Coast. I know that I'm just not fully familiar of the current incentives, but it's a great question. Thank you.
Okay, there is a similar question here. Uh, okay, does using mass timber in commercial and industrial buildings require special approval or additional fireproofing? Because it's really tough to, the codes for industrial and commercial buildings are tough, and to my knowledge that they require steel buildings.
Right. Yes. Because there's been a lot of research for these products, and there are third-party certificators that prove and work to prove the fire rating and safety of and the structural values of these products. So I believe it's like 3 hours proof fire, and the quality of that these products have is that when it burns slowly, it chars. So right now these products have approval for they're passing the fireproof. That's what I'm trying to say, because they had done testing for that. They had conducted testing. There is a laboratory, the National Forest Product Laboratory in Wisconsin. I know they do a lot of that, and those values and that information is passed to the people that update the building codes, and that's how they have been able to allow these new structures out there.
Okay, thank you. Additional question here, what happens with wood composite material that contains resins, and how can they degrade, how they can degrade, considering that the resins are mostly plastic compounds.
That's a very good question too. So these composites mostly have adhesives. I know a common adhesive for wood products is formaldehyde, actually, and I know there's been a lot of research ongoing in this area to make it more environmentally friendly. So like water-based adhesives or less harmful um, chemicals, but the resins, I'm not sure what resins they will be using. I think it's mostly adhesives, and I know there's like investigations, research on like soy-based adhesives, but in this case, when they have resins, what matters is that where is this product gonna end at the end? So there's gotta be a plan when you disassemble a building and where you're gonna put it. And so there's technologies that can process this compounds and probably take some of that for another purpose or separate it. I don't know if that makes sense. I know that I'm not sure what's the name of the technology, but I was reading like there's like even landfill technologies that will prevent the escape of this any harmful potential material that is inside, for example, a building product or any other materials. So it just to stay contained in that structure.
Thank you. I think that was the last question we have in the
Mhm.
chat.
Thank you. Thank you so much for the questions. And I hope I was able to address them the best I could.
Thank you. It's a really excellent presentation. Thank you for the information. Yeah, can we probably move to the next? Oh, you want to add something?
Sure. I'll move the slide first, but I have a link that I will put in the chat in case anyone in the audience wants to leave us a feedback and want us to bring a different topic for our next webinars. Please feel free to provide us with that information. And now I leave it to you, Dr. Tarek.
Yeah, this is just a quick announcement about the workshop we are offering next week and the 2 technical courses. So if you are in Greenville, we have, or near Greenville, we have 3 events next week, 2 technical courses and 1 workshop, 1 actually in Stamford, North Carolina, and 2 in Greenville, North Carolina. Dr. Irby, if you show us the last slide, again, we'll reach out back to you with a copy of the presentation, and we'll provide the link to the presentation. And here are some QR codes. If you are interested in joining or receiving our newsletters, please scan this QR code or visit our website. You will see the codes over there. And also, we hope that you can join us in social media like LinkedIn.
Thank you very much.
Thank you very much. Yeah.
I think the link will be sent with the presentation because I couldn't find it, but thank you very much for your attention, and I hope everyone has a great rest of the day.
Thank you.
Thank you, everyone. Thank you.
All right.
Thank you.
Bye-bye.